One way that the volume of solids of rotation can be found is through cylindrical shells. The concept is that an infinite number of shells are added up to fill the figure and find the volume of a rotated figure. When you find volume through cylindrical shells, you make slices that are parallel to the axis of rotation. This is unlike the method of disks and washers, in which slices are perpendicular to the axis of rotation. It is this distinction that is important to remember when solving problems using the shell method. When rotating figures around a vertical axis, the height of the cylinders will need to be in terms of x, and when rotating figures around the horizontal axis, the width of the cylinders will need to be in terms of y. So what we have to the left is a little model of the cylindrical shells. So the idea of a cylindrical shell is that it's composed of a larger cylinder with a smaller cylinder inside of it, and when you subtract the two, then you get the volume of the small cylindrical shell. So it's important to remember in the figure, if you can't read it, R2 is greater than R1. Okay, so volume of the cylindrical shell equals the volume of the outer larger shell minus the volume of the smaller cylinder. So volume equals pi R2 squared times height minus pi R1 squared times height. If you take the common factor of pi and h out, it becomes pi times R2 squared minus R1 squared, and then h. And then now, in this term right here, you can use difference of squares, right? So pi times R2 minus R1, R2 plus R1, that's equivalent. Okay, so now at this point, you need a little manipulation of the equation. Since we're trying to get it to this state, right? You want a 2 pi, so, and this works out nicely. So volume equals 2 pi, so you're multiplying this term by 2, R2 minus R1, and then R2 plus R1, and then this works out nicely, right? So you divide this term by 2, multiply by h. So R2 plus R1 over 2 is just the radius. That's the average radius of it. So it becomes 2 pi, and this term is R2 minus R1, that is delta R, that's change in R, times the radius times the height. So volume, and if you want to find the volume of all the shells, infinitely small shells in the interval, volume equals the integral from a to b of 2 pi, and then r is the same thing as x, that's the width, and height is the function, that's f of x, and then delta r is dx, that's the thickness of each small cylindrical shell. So there you have it. Alright, so over here I've created an example where you would need to use cylindrical shells to solve it. So first, when you read the problem states, find the volume of the solid generated by the region bounded by the function y equals negative 2x squared plus 4x and the x-axis, which is then revolved around the y-axis. Alright, so first we should begin by sketching the function. Y equals negative 2x squared plus 4x. To find the x-intercept of the function, you factor out a negative 2x, x minus 2. Alright, yeah. So the x-intercepts are when x equals 0 and positive 2. So what do we see here? If we graph the function, 0, 2, that's approximately what it looks like since both of the intercepts are passes, since the degree is 1. Okay, so, and since we're revolving it around the y-axis, those are what the slices will look like. They'll be small and vertical, since it has to be parallel. But if we were trying to use washers, what we would need to do is convert it so it would be in terms of y. And now when you see this function y equals negative 2x squared plus 4x, it might be hard immediately to convert that into terms of y. So what we would need here in this scenario is to use cylindrical shells. So there's an easy formula. 0 to 2, since those are the x-intercepts, of 2 pi x f of x dx. Okay, so volume equals 2 pi times the integral of 0 to 2 of x, and f of x equals negative 2x squared plus 4x dx. If you distribute the x, it'll become negative 2x cubed plus 4x squared dx. Okay, actually we can find the integral of this right now. So the integral of negative 2x cubed would be x to the fourth, then negative 1/2, plus, and the integral of 4x squared is x cubed times 4/3. And we know this works because if you take the derivative of this function, you should get this. All right, and then don't forget the limits of integration, 0 and 2. So equals it equals 2 pi times, and then we should plug this in. So 2 to the fourth is 16 times negative 1/2, it'll be negative 8, plus 2 cubed times 4/3, which is 2 cubed is 8, times 4 is 32 divided by 3. So 32 divided by 3. And then when you plug in 0 in either of these terms, it becomes 0, so that cancels out. So equals 2 pi times negative 24 over 3, which is equivalent to negative 8, plus 32 over 3. Okay, so equals, and what we have here, negative 24 plus 32, that equals positive 8 over 3. So we can simplify this to 16 pi over 3 cubic units.